Okay, we've got a boat due east of an island. Let's indicate an island over here. We'll put a boat in due east of it. And the driver of the boat wants to get to the island as soon as possible. At full throttle, the boat does this, and the water is moving northward. So I don't want the boat actually pointing that way if it's going to get to the island. Let's get the water indicated in there. So I got the water moving northward. At call it VW, 2.5 meters per second. And I'll go ahead and label this the island. Now let's imagine driver of the boat headed straight at the island. What would happen? Well, if the water was still, the driver would actually go straight toward the island, headed due west. But the water's going to carry the boat northward, so the boat would actually wind up here someplace. And I should indicate those, but let's erase this boat. First, that's the wrong way for it to be pointed, and then indicate the compass directions on my diagram. So it's due east of the island, west is to your left, and the driver should probably head, should definitely head in some southwesterly direction. With its at full throttle, so I'll call that the velocity of the boat relative to the water in magnitude has got to be equal to 4.6 meters per second to get there as soon as possible. Alright, then the water will carry the boat northward, and if the driver picks the right direction, the exact right angle in which to head, call that theta, where that line is due west, with the right angle theta, the boat will go straight toward the island. It'll look like it's going somewhat sideways because of the water carrying it northward, but it'll actually be going directly toward the island. So our little vector addition problem is that the velocity of the boat should be equal to the velocity of the boat relative to the water plus the velocity of the water. This will be the total velocity of the boat, say relative to the island for instance, and it's going to be the velocity of the boat relative to the water plus however fast and which way the water is carrying it. And we know that's how fast it's carrying it northward. So we'll put the velocity of the boat in relative to the water. I want to draw a little vector addition diagram. Call that the velocity of the boat relative to the water, which I know is 4.6 meters per second. And then I got to add to that the velocity of the water. And I drag it up so that it's even with the starting position for my vector diagram, because I want the resultant to come out to be due west, which would be the direction directly toward the island. This is the velocity of the water, and it's 2.5 meters per second. And then the resultant is the desired due west velocity, VB, of the boat. So I'm adding those vectors together. I got a nice little vector addition diagram. Because in this problem I've got a right angle, I don't have to bring out the full complement of tools of vector addition. This is an easier problem than the usual. What I'm looking for is this angle theta at which the driver has to aim the boat relative to due west in order to make it so that the boat actually goes due west. VB, we should be able to calculate at this point. I'll write down from Pythagorean theorem, I can write V B squared plus VW squared. That would give me the magnitude of the velocity. I'm more interested in this angle at which the driver has to point. So let's back up a little bit here, and I think I'll go the sine of the angle is equal to VW divided by VBW. So the angle itself is going to be the arc sine of that ratio of VW to VBW. So the angle theta that I'm looking for at this point is the arc sine of 2.5 meters per second divided by 4.6 meters per second. Which evaluates to 32.92 degrees, and I want to round that to 2 sig figs because input data was given to 2 sig figs. So that would round to 33 degrees. So the angle at which the boat should head, this theta, is 33 degrees. I want to make sure that answers the question. In which compass direction should the boat be pointing so that its velocity, its total velocity, is actually straight toward the island, and indeed the 33 degrees is the answer to the question posed in sac111 problem number 2. The only thing that remains to do is to interpret this result for the reader. This direction is due west, and we're that angle 33 degrees south of west. So I can put that down as an answer in words. The boat should be pointing, or should point 33 degrees south of west. And that's a complete answer. And because west is at a compass heading of 270 degrees, there's north, east. Remember, compass directions are measured eastward from due north. And we're talking about a compass direction like this, that's 33 degrees south of due west. Or south is in this direction, of course. That's equivalent to 270 degrees minus the 33 degrees, or you could say the boat should head in a compass heading. The boat should point in a compass heading. Let's say it should have a compass heading of 237 degrees. This always means east of north, so you don't have to add anything on there. I do want to check to make sure I did the arithmetic right. I wanted to add up to 270, 237, and 30 would be 267, and another 3 would be 270. So this would be an okay answer as well, but it's this is the one that I choose to give as my final answer. Keep in mind this would be a perfectly acceptable final answer down here as well. Okay, that does it for SAC 111 problem number